Alright, so we're on lesson 3 of our geometry unit entitled the area of right triangles. So we're continuing from yesterday's. And our ICANN statement is this: I can show the area formula for a triangular region by decomposing a triangle into right triangles. So I'm going to start with any triangle. And what is it telling me I can do with that triangle? Well, it's telling me I can decompose it. Decompose it means break up. So what am I breaking it up into? Well, I'm breaking up into right triangles. So I can take any kind of triangle, and somehow I'm going to learn today that I can make it into right triangles, or a triangle with 90 degrees in it. Okay, so first a vocabulary review. Right angle, what is that? Well, right angle is a 90-degree angle. Parallel. Parallel means that my lines are never touching. So if I were to continue these two lines forever and ever, they would never touch. They are parallel. My next one is area. Well, area of a rectangle is just base times height. And a triangle should be easy, is a three-sided shape. That tri, my prefix, means what? It means 3. What if I had this, though? What if I had area of a triangle? Would it still match with base times height? No, it wouldn't. Remember, area of a triangle from yesterday's lesson is 1/2. Why? Well, because a triangle is half of the shape of a rectangle. So from yesterday's lesson, remember, if I have this right triangle, that is half of the shape of a giant rectangle. So I'm only taking half of that area. Okay, let's look at these two triangles. What is different between the two triangles below? Well, hopefully the very first thing you see is this triangle has what? It has that right angle. Well, this triangle doesn't have any right angles. How do we find the area of a right triangle? How do we find the area of this guy? Well, that's from yesterday's lesson. Remember, it is 1/2 base times height. If I think of this triangle as coming from a whole square or a whole rectangle, I can see that the triangle part is only taking up half of the area of the whole entire square. So that is where this 1/2 comes from. How do we know which side of the right triangle is the base and what is its height? Because in order to use this formula, I need to know its base. I need to know its base, and I need to know its height. So how do I know which side is its base and height? Well, remember that right angle is very important. The base and height will always be perpendicular, or at right angles. So whichever two sides touch my base and height, those are going to be my base and height, whatever angles touch that right angle. How do we calculate the area of this guy? Well, looking right above, it says my base and height are always perpendicular. My base and height are always the sides touching that right angle. Do I see any right angles in here? I don't. So actually, I don't know how to find the area of that triangle yet because there's no right angles. We need to find the height of a triangle. Height means how tall it is from the bottom to the top. Do I know how tall it is from the bottom of my triangle to the top? I don't. So what I need to do is I need to do some little problem solving. I first need to draw a line called the altitude or height that shows how tall the triangle is. Where can that line go? Well, if I draw a line from here to here, that doesn't show me how tall it is, because I need to get all the way up here. If I draw a line from here to here, that's not showing me how tall it is because I need to go from the bottom to the top. So where can that line be drawn? Well, there's really only one spot on my triangle. It's from the bottom to the top. So that is going to be my height. What shapes do I see now? Now that I've drawn this line, what shapes do I see? Well, you should notice that I see 2 right triangles. I have a right triangle here and a right triangle on the right side. Can I find the area of right triangles? Yes, I can. I used that formula from yesterday, 1/2 base times height. which is the same thing as base times height divided by 2. Remember, multiplying by a half, the same as dividing. Okay, so now I need to find the area of these two shapes. I measured my shape out, and these are the lengths that I got. So what do I need to do first? Well, first, for each triangle, my blue and my red, I need to find my area formula. So it's that 1/2 base times height. What do I need to do next now? Well, hopefully you remember I need to plug what in? I need to plug the answers in. So 4.5, that is my base. My base is the bottom. And this 3 is my height, how tall it is. So what do I do next? Well, I just multiply them together, and I get 6.75. So 1/2 times 4.5 times 3 is 6.75. Now what do I do for this blue triangle? Well, the blue triangle, I know its base is 1.5. What about its height? I don't see any number in blue over here. Well, hopefully I realize that 3.5, or 3 inches, that's going to be what? This 3 inches is also the height for right here. This red line is the same as this blue line. So I can plug that 3 inches in also for my height. What do? I multiply 1/2 times 1.5 times 3, and I will get 2.25. Now, what is the area of the whole triangle? Well, I know the area of the red triangle and blue triangle are these two numbers. So what's the area of the whole triangle? Well, if I add my red triangle to the blue triangle, I'm going to get the whole number. So 9 inches. 6 and 75/100ths plus 2 and 25/100ths is 9 inches square. Now, this was a lot of work, trying to find the area of 2 triangles instead of 1. So there must be an easier way. Well, that easier way is, what if I think of this triangle as being inside a rectangle again? Well, I should notice that what? This red triangle is half of the area of this, and the blue triangle is half of the area of this. Do you notice anything? You should notice that the original triangle is half the area of the rectangle. Does that sound familiar? It should sound familiar from our formula. 1/2 base times height. So it's looking like we can use this formula for any kind of triangles, not just right angles. Did that original triangle represent half of the area of the rectangle? Why or why not? Yeah, the original triangle did represent half of the area of the rectangle. What is the length of the base now? The length of the base is 4.5 and 1.5. So 6 inches. Now what is the height? Well, my height is still going to be that 3 inches. So can I calculate the area using the formula we discovered yesterday? My length, I add these two together to get this 6. So what was my formula from yesterday? Well, my formula was 1/2 base times height. So I'm going to rewrite them in using those numbers. 1/2 times 6 times 3. And what do we get when I do that? Well, this is 18. And then 1/2 times 18 is 9. Hey, look at that answer. That answer, 9 inches squared, that's the same one we got when we found the area of our 2 triangles. So that formula does look like it's going to work. Now, did we get the same area each time? Yeah, I did. It was 9 inches squared each time I solved it. However, we need to see if this works for every triangle, not just the one example we did. So here's your assignment. You're going to solve these problems on your piece of paper, on your notes. these 4 problems. Alright, so what was the area of the 2 right triangles? Well, here is the area of one. This triangle is what portion? Well, it is this portion. And when I multiply them out, I get 54. Now, what's the area of my second triangle? Well, the area of the second triangle is this one right here. So when I multiply them out, what do I get? Well, my 12.6 is right here. My 12 is there. Multiply them out. Now, what's the area of my entire triangle? Well, my entire one is I add them together, and I get 129.6. Now, what's the area of my whole triangle? So what if I want to find it using just my regular formula, so I want to find the area of one triangle? Well, its base is 21.6. The length of the whole triangle, I add these 2 together. I get 21.6. Now I'm going to use my formula, 1/2 base times height, to see if it's correct. So I put those numbers in. Its base is 21.6. Its height, how tall it is 12. And when I multiply 1/2 times 21.6 times 12, gets this. What do you notice? They are the same. Okay, let's do it for our next one. Let's try it starting with the area of the entire triangle first. So let's look here. My base, because I need to find that base, is what? Well, it's 8 plus 3.9. So 8 plus 3.9 is 11.9. So my whole base is 11.9. How tall is it? Well, it's 5.2 inches. So I'm going to put all those numbers into my equation right up here. And when I multiply them out, I get 3.9. Okay, now what if I want to find the area of just my 2 smaller triangles? Well, I need to find the area of this shape. So its base is 8, its height is 5.2. And when I multiply them out, I get 10.14. Now I need to find what? The area of this triangle. So 6.5 and 3.9. So when I multiply them out, I get 20.8. And my area of the whole entire triangle is I add these 2 together. So when I add them, I get 30.94. Alright, let's look at this next one. Why is this one different? Well, it's different because now I'm working with fractions. So my area is what? My area of this triangle, the big one, is 2 and 5/6. My area of what? This smaller triangle, super skinny triangle, well, that's also going to be an area in fractions. It's going to be 1 and 13/72. Notice how we changed the improper, or the mixed number, to an improper fraction. Now, how do I find the area of the whole triangle? Well, I'm going to add these 2 together. So when I add them, I get 4 and 1/72. Now that was a lot of work. So let's see if I can find the area of just the whole entire triangle the first time through. Well, the area of the whole triangle is what? Well, I need to find my base, so I'm adding these 2 together. So it's 2 and 5/6 for my base. Okay, now what do? It is base times height. So I put those numbers in, and I multiply them. And look, when I multiply them, I get a mixed number at the end that matches my mixed number over here. 4 and 1/72 inches squared. Here's our last one. What is the area of the entire triangle? So the entire triangle is the area of the whole shape. Well, first, I'm looking for my base, wherever that right angle is. My right angle is here, so my base is whatever touches that right angle. So it's 34 plus 12 is 46. My height is how tall it is, so it's 32 meters tall. So I plug those in. Now what? Multiply them out and I get 736 meters squared. Now let's look at the area for two right triangles. My area of the first triangle is going to be this guy. Why? Because he's touching that right angle. My base touches the right angle at 34. My height is 32. So I plug those numbers in, multiply them out, and get 544. Now I need to find the area of my smaller one. Base is 12 because it's touched the right angle, and it's also 32 meters high. So I plug those numbers in, multiply them out, and now I have two triangles, so I need to add them together to get the area of the whole entire shape, which is 736. And look, once again, they match. So it looks like I can use this formula for any kind of triangle that I come across. Alright, can we use the formula area equals 1/2 base times height to calculate the area of triangles that are not right triangles? Explain your thinking. Yes, we can use the formula for more than just right triangles. We just need to determine the height, which is not, this is the most important part, the height is not the length of one of the two sides. So what does that mean? If I have a triangle like this, 10, 8, 6, I can still use this formula. Its base, though, is going to be perpendicular to its height. So I need to draw a line from the top to the bottom that's at a right angle. This is going to be its height. This number, its height, is not the same ever as its sides. So here I have 10 and 4 that I'm multiplying. So 1/2 times 10 times 4 equals, this is 40. 40 divided by 2 is 20. So as long as you find the height, height is from the top to the bottom, you can use this formula for any triangle. Okay, examine the given triangle and the expression. Explain what each part of the expression represents. So this each part means, what does this represent? And what does this represent? Well, the 11 feet represents the base of the triangle. It's 11 feet long, 3 plus 8. This 4 feet, you should see, comes from right here. So it represents my height, how tall it is. Alright, here's our next one. Joe found the area of a triangle by writing A equals 1/2 times 11 times 4 inches. Caitlin found the area of the same triangle by writing A equals 1/2 times 3 plus 4 plus 1/2 8 times 4. Explain how each student approached the problem. Well, you should notice first is, what do you notice about this 11 compared to why it's different in here? Well, you should see that this 4 inches appears in both, so it's the same. But what's different is this 11, and I have a 3 and an 8. Hopefully you can see, make a connection that this 3 and 8 is just 11 broken up. So what Joe did is he combined the two bases of the triangle first. So if this is my triangle, he's going to combine the two bases. So here is Joe's. He combined them to get 11. Caitlin calculated the area of the two smaller triangles. So she found the area of this triangle and the other triangle. And then she's adding them together. They're still going to get the same answer because we've been showing you with all these problems that you can find the area of two right triangles and add them together, or the area of the entire triangle and add them together. So they're still going to get that same answer. Alright, the triangle below has an area of 436, or 4 inches and 4.76 inches. If the base is 3.4 inches, so my base is what? My base is 3.4. Let h be the height. Explain how the equation 4.76 equals 1/2 times 3.4 inches times h represents a situation. Well, the equation shows that area equals 1/2 base times height. So my area, the equation is telling me, is 4.76. This 3.4, or 3 4/10, well, that is my base. So I'm taking that base and I'm putting it into my expression. So the equation shows the area, 4.76, is 1/2 the base, 3.4, times the height h in inches. Okay, now we're going to solve that equation. So I'm solving and I'm looking for the variable. What does my variable equal? So my first step is I rewrite my problem. My next step is what? My next step is I need to multiply 1/2 and 3.4, and I get h. What is my final step that you see? Well, the final step is I need to divide it by 1.7. I need to get this variable by itself. So I'm going to divide it by whatever number is next to the variable. And I'm left with h is 2.8 inches. So its height is what? Its height is 2.8. Okay, so my closing. What did we learn today? When a triangle is not a right triangle, how can you determine its base and height? Well, the height is a line segment from a vertex. This word means corner, so it's a synonym. My height is the line segment from a vertex of a triangle to the line containing the opposite side that is perpendicular to the base. So all that means is, if I have a triangle that's not a right triangle, I just draw a line from a corner to the opposite side, and it needs to be at a right angle. Alright, now what do I do next? Well, my next question is, how can I use your knowledge of area to calculate the area of more complex shapes like this one? This is not a triangle. It's not a rectangle. So how can I use my knowledge of area to find the area of this? Well, remember, at the very beginning of our geometry lesson, I said all we're working on is finding area of parallelograms / rectangles and triangles. So I must be able to break this up into a triangle or rectangle somehow. So what I need to do is I need to decompose or break up the shape into smaller shapes for which we know how to calculate the area and add all the areas together. So look, I can break this one up into what? I can break it up into triangles. And now I know how to find the area of any triangle. So all I do is find the area of each triangle, and then I add them all together. Alright, here's your exit ticket. Calculate the area of each triangle using two different methods. Figures are not drawn to scale. Okay, so you need to find the area of the whole entire triangle using two different methods. So method 1 is using two triangles. So triangle 1 and triangle 2, and adding them together. And that second method is finding the base of the whole triangle. Find the base of that whole triangle and multiplying it by the height using that formula, that 1/2 base times height. All right, good luck.